talk about sponge. It's time to talk about sponges, you and me. Sponge. So here it is, number one. What does porifera refer to? It means has pores in it. Pore bearer. All right, so that's what it means. It's because they're covered with tiny little holes. You know this about a sponge. Number two says, what does sessile mean? It means they stay put. It means they're attached to a single spot for their whole life. They don't go anywhere. They can't travel around. And you say, but wait a second. One of the characteristics of animals was that they move. Time out. More on that later, but congratulations on remembering that fun fact. Thank you. Look at all that sponge. Okay, so how do we define this whole phylum? Sponges, right? Porifera. 4 characteristics. Here they are. All sponges are multicellular, heterotrophic. They lack cell walls. All right, this is true of all animals, of course. And the important thing about sponges is that they are very, very few specialized cells. All right, we'll talk about how that's important soon, but sponges have, depending on who you ask, maybe about 5 different types of cells in their whole body. And you have in your body thousands of different types of cells. So we are much more specialized. So sponges, they are simple. Okay, so sponges, I just said, are super simple, right? Well, they don't have a mouth. They don't have a normal gut for digesting. They don't even have tissue or organ systems. So how do they do their normal thing? It's pretty simple. They use a flow of water. They create a current of water coming into their body and flows through their body, and they use that current of water that they cause for feeding, respiration, circulation, excretion, all of it. Okay? So they use that water flow to help them do their business. So the symmetry of sponges. So sponges are all asymmetrical. They don't have any symmetry. There are asymmetrical creatures in other phyla, but all sponges are asymmetrical. So no body symmetry. Don't forget about that. So if this water flow through a sponge is so important, then you should keep in mind that we ought to think about it. Okay, that was an eloquent way of starting this slide. Anyways, look, we've got a big central cavity, most sponges anyways. And this is where water comes into, all right? So it's circulated into this large central cavity, right? And then exits through the opening called an osculum. So water comes in through these little pores into the central cavity and out through the osculum. So you can see the direction of water flow like this, all right? It's that direction of water flow that, again, allows sponges to do all the things that they do. Okay, we have these things called choanocytes. So this is number 7 in our notes. So choanocytes are otherwise known as collar cells. You see these little cells with a single flagellum, and they've got like a little protective collar around them. So they are the things that have the flagellum that cause a constant, steady flow of water. So they cause this, this water movement, right? Draws water in through the pores into the central cavity and out of the osculum. So thank you, choanocytes, for doing that. All right, sponges also have a little bit of structure in their body. Got to maintain their shape somehow. They're pretty soft and squishy, but they also have some support structures, and they are called spicules. All right, these little spicules are little silica or calcium carbonate, so they're kind of hard. Usually spike-shaped. They come in a variety of shapes, but spicules provide a little bit of like internal structure for a sponge so they can have and maintain a body shape. So how do sponges feed? Number 9. Well, they filter little particles out of the water, and here's how it works. They use their little choanocytes, their collar cells, to create this current of water, but they've got some mucus around that little collar. All right, so little particles get stuck to it. Right, some like snot. So little particles get stuck to it as they travel by in the current of water that they caused. Okay, so there are some other component parts to like going through digesting the captured things, which we don't need to worry about. But number 9 is just about that current of water brings in little particles that get stuck on the collar on the choanocytes. So number 10 is about how do sponges protect themselves. Well, as any kind of sessile or non-mobile organism has to do, their only defense is really chemical, right? So you can have some physical defense, like have spines or barbs all over you, like some plants do, but mostly it's chemical defense, and sponges do this too. So a lot of sponges can produce some toxins that at least make them not tasty. So things, grazing on the ocean floor, don't snack on squishy little sponge. They taste gross, or I don't know, they make you sick, and throwing up in water is pretty gross. All right, so we'll talk a little bit about reproduction here. The previous slide mentioned that they reproduce sexually and asexually. We'll talk about asexually in a second. But number 11 asks specifically about something called larva. So in any kind of animal, if there's a larval form, it's where you have an immature stage that is different from the mature stage. So we're talking, in this form, the baby version of a sponge, which can swim around, doesn't look anything like an adult sponge. Right, so we have, I don't know, they're mobile basically is the difference, right? So number 11, the follow-up says what makes sponge larvae unlike adult sponges. They can swim. They're these little cluster of cells that don't look like anything. They're microscopic, and they swim around and they follow current of water until they land in a happy place and grow into their own sponge. So other examples of larvae might be things like a tadpole doesn't look like a frog, right? A caterpillar doesn't look like a butterfly. So it's when you have immature forms that are different from adult forms. Okay, and asexual reproduction is by a process called budding. So budding is just where a little tiny piece breaks off and then grows into a whole new organism, right? So if humans could reproduce by budding, I could just chop off one of my fingers, and sit it on a maybe dinner plate, and then that would grow another John Kinsley. And now there are two of us, and the world is twice as good as it was before. Anyway, sponges do this asexually by budding. There's no sexual reproduction, no meiosis. Nope, just a little chunk comes off, grows into a whole different sponge. So that's kind of a handy way. Some other creatures can do that. You know about chopping off starfish arms, right? That works. Because they'll grow them back, and then the starfish arm will grow a starfish. So similar to that. Okay, here's today's secret. And Kirsten, make sure you tell your mother this time, because she doesn't like being left out of the loop. Anyways, secrets. So here it is. I go through waves of chewing my fingernails. It's a terrible juvenile habit. And I'm 39 and I still do it sometimes. And I'll go through phases where I find myself chomping on them and I'm like, oh no, don't do this. And then what I do is I paint on some of this clear nasty tasting stuff onto my fingernails. It's called Mavala Stop. It's real bitter tasting stuff. You can't see it. It's made in Switzerland. Anyways, you can buy it on the internet. Amazon's fine. Mavala, M-A-V-A-L-A, Mavala Stop. I don't know how to pronounce it. That's probably it. Anyways, it's real bitter tasting, and so when you're absent-mindedly just doing your thing and you taste that, oh gross, and it reminds you. So I'll go through phases where I'll have to paint that on my little fingernails for, I don't know, usually no more than a week or a week and a half before I break the habit for another couple months, and then it'll be back again. So I don't know how to permanently stop it, except for painting my fingernails every day or two for, I don't know, like a year. I don't know. There are bigger problems to have than to be occasionally chomping on my fingers. So I guess it's not that bad. Except for, remember, keep your hands away from your face.